This is lesson 9.2, secant-secant theorem and secant-tangent theorem. Okay, so just a couple more theorems to look at. And by the way, this one does have a construction on it, so you might want to grab your compass and your ruler for it. So the next two definitions, so we already know a chord. A chord is a segment that joins two endpoints inside the circle. A secant is a line, so it extends infinitely and it intersects the circle in two spots. Okay, so it's still intersecting it, but it's passing through it. Okay, so they technically considered this a secant too. If it like starts and then goes through, even though it looks like a ray, they actually consider that a secant also. So then a tangent is a line that intersects a circle in exactly one point. So what you guys need to know about tangent lines is that if you were to like connect the point of tangency to the center, okay, what that's going to create for you is a right angle. Okay, so think of like your tire on a car, you know what I mean? Your tire has a point of tangency, I can never say that word, okay, and if you were to take the center of the tire and go straight down, obviously it's going to be perpendicular. That's the idea of tangent lines. Okay, so in the diagram below, this is just one of the constructions that they had on the Regents exam, and it wanted us to construct the tangent line to circle O intersecting at point A. Okay, so this is how you would do it. The first thing you would do is you have to kind of like extend out your line with a ruler. Okay, then what you're going to do is you have to pick a point equidistant from A. So like if you want to, there's a lot of ways you could do this, but like, for example, if you want, you can like kind of copy the length here of O up this way, like that. Okay, so all I did was I went here, flipped it there, so I had two equidistant points. Now from those 2 points, you can just bisect it. So open it up more than halfway. I'm gonna try to make mine kind of thin, draw an arc, okay, flip it, draw an arc, and then get your ruler and connect these 2 points together. And there you go. Okay, now mine's not great. It's got a little bit of a lip there, but you guys, it's because I'm looking at it sideways. But anyways, so that's pretty much what they're looking for on that one. They just wanted you to construct it. So you guys can turn the page. Okay, so let's get to the rules. So the first rule is secant-secant. So secant-secant, this is how I always remembered it. It's kind of corny. I think French. It's oui, whole times exterior, whole times exterior. So whole times exterior will equal whole times exterior. So if you look at this picture, the whole secant times the exterior part will equal the whole secant times the exterior part. So in other words, this part right here inside, I'm not going to use. Okay, the only time I need to use that is say they gave me the whole thing and then this part, I would subtract it to get the exterior part. Okay, so this is what I'm talking about when I say exterior though, the parts that are outside the circle. So let's try it. So like for the first example here, it says, given the circle of two secants, find x. So first off, I need the whole secant on this one. So the whole secant on that one would be x plus 4 times the exterior part. Okay, the exterior part's 4. So it's 4 times x plus 4. I'm going to write it this way because I know how to distribute that. I don't like putting the 4 at the end because I don't like distributing backwards. It's kind of annoying to me. Okay, so that will equal this whole secant, which is 16 times the exterior part of 6, right? That's the exterior part. So now all I have to do from there is just simplify that. So I would get 4x plus 16 would equal 16 times 6 is 96. Subtract 16 on both sides. 4x would equal 80. Divide both sides by 4, and you get x is 20. And that's all they wanted was find x. Okay, so that's the first one. Let's try another one. Now this one, there's a lot of different ways that they can ask it, which is why we have a lot of examples. So for this one, the whole secant is 24. So it's whole times the exterior part of 10, okay, whole times exterior, will equal, this time they're calling the whole thing x and the exterior part 8, so this is really easy, it's just going to be 8x. So then I would get 240 equals 8x, divide both sides by 8, and I would get 30 is equal to x on that one, okay? For number 3, whole thing is going to be x plus 5. This whole side, might as well do it, is going to be 10. So it's going to be 5 times x plus 5, x plus 5, will equal whole times exterior, or 10 times 6. So you get 5x plus 25 will equal 60. And then you would subtract 25 on both sides. 5x is 35, divide by 5, and you get x is 7. Okay, so then we can turn the page. Okay, so that's secant, pretty easy. Just think wee, think French, and it's whole times exterior equals whole times exterior. Okay, so then we have secant-tangent. So what this is it's still like whole times exterior, but then you guys see how this is a tangent because it only intersects the circle in one spot. This is a secant because it's hitting it twice. So it will equal the secant, or the tangent line, squared. So a squared will equal whole times exterior. Okay, so let's try it. So looking at number 4, this would be whole thing, whole secant, so x plus 5, times exterior, which is x, so x times x plus 5 would equal the tangent squared, or 6 squared. So then I would distribute that. I would get x squared plus 5x equals 36. Now, if you notice, we have a problem. This can only be solved because it's a quadratic. Like, you can't just go ahead and isolate the x squared because of that x term. So what we're going to do is like move the 36 to the left side, put it in standard form. So now I have x squared plus 5x minus 36 equals 0. And then I would factor that. So factor 2 numbers and multiply to give you 36, but subtract to give you 5 would be 9 and 4. This sign will always go to the bigger number. This tells you they're different. So then I would t-solve. I get x is -9, x is 4. I reject the negative number because I can't have negative lengths, so that answer must just be 4. Now you guys are going to see there's going to be some factoring ones along the way. And it's because the Regents just expects you to know that because you learned it last year. So that's all it is just factoring. Okay, so then for number 5, same thing. Whole thing is 12. So the whole times the exterior part of 4 would be equal to the tangent squared, or x squared. So 12 times 4 is 48, is x squared, square root both sides. I think I just like simplified this. It doesn't really say, but I just like broke it down just out of habit. And you end up getting 4 square roots of 3. Okay, so then the last one, and you guys are going to notice the last question is always like kind of combining a bunch of different things. So it says you're given the circle with a tangent, secant, and a chord, and it wants you to find what x is. So the hint is you have to figure out what y is first. So the first thing that you're focusing on is this intersecting chords rule, okay, from the previous lesson. So I can figure out y pretty easy. I know that 8 times 5 would equal 4 times y, right? Like this times this equals this times this. Not even looking at this part out here yet. So this ends up being 40 is equal to 4y, divide both sides by 4, and you get 10 is y. Okay, so now we can kind of figure out what x is going to be. So this whole secant is 4 plus 10 plus 5, or 19. So it's the whole thing times the exterior part, 5, would equal the tangent squared. So 19 times 5 is 95, and we would just square root that. And that can't be broken down, so we would just say that is my answer for x. It's just the square root of 95. Okay, guys, that's it for this lesson. Thanks.